Okay, today we are going to start with the thermoplastic and thermosetting. Basically we know what is a thermoplastic and thermosetting. So today we will start with the difference between it. So first one is the thermoplastic. As we know, these are the compounds or a plastic material which gets softens on heating, whereas thermosetting is the one which get hardens on heating. Okay. So first point in this is thermoplastic are formed by the addition polymerization, where there is a just a addition of a monomers. There is a no elimination as such of any molecules. In thermosetting, it is formed by the condensation of a monomer. So the condensation means there is a elimination of a molecules like a water molecule, ammonia molecule, HCl molecule. So this is our condensation. Okay. So the addition and condensation. Thermoplastic is formed by the addition polymerization. Second one is, it is formed by the linear monomers. So the linear monomers are in a straight chain. These are the linear monomers, whereas the thermosetting plastics are formed by cross-linked polymer. So we can see this is a cross linkage of a polymer. Okay. Now these thermoplastic polymers get softened on heating. Why it gets softened on heating? The reason is, as we can see the linear chain. Okay, so what happens, these linear chain on heating are able to move, okay, are able to move in a different directions. They are free to move and therefore they get softened on heating. Whereas in a cross-linked polymer, what happens, the structure remains as it is. Okay, so on heating also what happens, the whatever is the structure, whatever is the cross linkage between them, it remains as it is. Therefore it do not soften on heating. But when the heating is in excessive, that time there is a deformation takes place. That means it gets charred. Okay, so on these thermoplastics get softened on heating as well as it gets hardened on cooling. Whereas the thermosetting is what? It is firstly do not get softened on heating, but it completely get charred. Now the next point, these thermoplastics are formed by the bifunctional monomer. Okay, now what is the bifunctional? For example, ethene molecule. So there are two sites of reactions, that is two reactive sites, hence it is called as a bifunctional. Whereas the thermosetting polymers are formed by, these are formed by the four reactive sites. So the reactive sites are four. Okay, so we can say thermoplastic is formed by the addition polymerization, thermosetting by the condensation. These are formed by the linear monomer, these are formed by the cross-linked polymer. These soften on heating, whereas these do not soft on heating and it gets charred. Whereas this is the thermoplastic are formed by the bifunctional monomer and thermosetting are formed by more than two functional groups. The next one is, these are soft and not brittle. Okay. These are soft, flexible and not brittle, whereas these are hard, strong and brittle. So this we can say are the points for difference between the thermoplastic and thermosetting polymers, and which is very important. Okay. The next point we are going to see is the compounding. Now compounding means the ingredients by which a plastic is made up. Okay. So for the formation of a plastic, we called as the ingredients or compounding. The first point here is a resin. Now resin is the main constituent when there is a formation of a plastic. Why it is a main constituent? Because it acts as a binder. Clear? So the role of binder is to bind all the other constituents that are taking part in a compounding, like plasticizers are there, stabilizers are there. So different ingredients in the formation of a plastic that is used, with the help of this binder it is binded together. So therefore we say that resin is the main constituent by which it is used for the binding purpose. Clear? So this is the resin. The second point or second ingredient is a filler, or we also called it as a extenders. Now role of a filler and extenders. The role is what? It reduces the flexibility. Okay, many a times the plastic, the filler is added to remove or to decrease the plasticity of a compound. Okay, so the main function is a decrease the plasticity, or we can also say the flexibility. Okay, another thing is filler also provide a tensile strength, because if the plastic is very flexible, what we can say, it is of a no use, because it cannot be molded into the different shape. So we need a solid, the plastic to be a solid intact, or it should have a complete tensile, strong tensile strength, so that it can be molded into any kind of a shape. Now what happens, by the addition of a fillers, it also increases the tensile strength, or we can say it provides hardness also to the plastic material. So this is our role of a fillers or a extenders. It also then it is also used to decrease the cost of a plastic, because if the fillers are added, we can say the more amount of a plastic can be used, and therefore it decreases the cost of a plastic. Then the next one is the plasticizer. Now this plasticizer is again very important, because it imparts now the flexibility. It is exactly opposite to the filler, because as we say, fillers are added to decrease the plasticity. Here plasticizers are added to increase the plasticity, that means to increase the flexibility. Okay, for example, suppose these are the strands of a plastic. Okay, these are the strands of a plastic, and here I have put no plasticizer. These are the strands of a plastic, and whereas here I am putting some plasticizers in between. Now we are going to see what is the mechanism that is exactly happening over here. You can see these dots. What these dots are meant over here. These strands of two strands of a plastic are having this plasticizers molecule. So now what happens, there are the intramolecular forces of attraction. Between all these strands there is a molecular force of attraction. Because of this is having a, we can say this is not flexible, because there is a interactive forces between this. Okay. So by addition of this plasticizer, these forces are removed, because these molecules of a plasticizers are keeping the two strands of a plastic away from each other. Okay. So because of addition of this plasticizer molecule, all these plastic strands are away from each other, which reduces the intermolecular forces of attraction. Okay. So because of which the intermolecular forces are less now, and therefore this can freely move. These all strands can be freely moved, and as it is freely moving, we say the flexibility is increasing. Okay. So in this case flexibility is less, because the intermolecular forces of attraction is there between all these plastic strands, and thus it is having an intact position and the flexibility is less. Whereas here the plasticizer molecules occupy the space between the different plastic strands, and because of which it can be freely moved over each other, and therefore we say that the flexibility is increased. Okay. So this is the role of a plasticizer, where In one case we saw that without plasticizer it is having less flexibility, and with the plasticizer it is having more flexibility. Okay. So the next is lubricant. Next ingredient of a plastic compounding is a lubricant. Now the role of lubricant, as we know, lubricants are nothing but they are the like waxes, oil, which reduces the friction, okay, between two matter. So same is the role of a lubricant over here. For example, waxes, okay. So lubricant plays the same role over here. During the molding, it may happen that the plastic material may be sticked into the mold. Suppose this is a molding and we put a plastic material into it, it may stick to the wall of this molding part. So in order to avoid this sticking, we add the lubricant like a wax, okay. So it reduces the friction between the walls of a molding part as well as the plastic, and hence it acts as a very important thing. It also, the main function is also that it provides a glossiness, okay. The glossiness is provided, is imparted into the plastic because of a lubricant. So this is again another important role of a lubricant. Then the next part is a pigment. It is quite obvious that pigments are used for the coloring purpose. So the coloring, it is a coloring agent. It can be a natural or synthetic dyes, okay. So the pigments imparts color to the plastic material. So this is again very important. Different colors are given to different products by using natural or synthetic dyes. Then next is a accelerator. The role of now accelerator, for example we take H2O2, hydrogen peroxide. Accelerator are nothing but the catalyst, okay. Now the role of catalyst, as we know that it increases or it accelerates the rate of reaction without taking part in a reaction. So same thing is a role of accelerator over here. For example, I have taken a H2O2, that is a hydrogen peroxide. It will not take part in a reaction, but it will definitely accelerate the rate of reaction, okay. Then next one is a stabilizer. Now what is the need of adding stabilizer? Because we are heating the plastic to different temperatures, okay. So there may happen that because all these things are ingredient, okay, when we are adding lubricant, pigment, accelerator, everything into the plastic for the formation of a plastic, that time it may happen on heating something get decomposed, okay. Like pigments are there, they may be natural or synthetic. So it may happen that on heating it may get decomposed. So in order to avoid these things, in order to prevent this decomposition, what we do is we add a stabilizer. So by adding the stabilizer, these things are avoided, like a decomposition of any kind of a ingredient which are added in a plastic formation, okay. So this is the role of a stabilizer. So with this we complete our plastic ingredients, or we can say a compounding, okay. So in that we have seen the resin, then fillers, then plasticizers, lubricants, pigments, accelerator and stabilizer. Each one is having its own importance and role in a compounding of a plastic. Next point that we are going to see is phenol formaldehyde. Preparation and properties and uses of first one is a phenol formaldehyde. Okay. Phenol, the title itself tells that phenol plus formaldehyde. This is a phenol plus this is a formaldehyde okay. This phenol plus formaldehyde gives you the product, two types of a product. One is a ortho and another one is a para. So there is a mixture of a two products that is formed. This is a ortho plus para product. Okay, this is a para-hydroxy, this is a para-hydroxy and this is ortho-hydroxy, methyl phenol. Now we will take, for example, we are going to see the phenol formaldehyde. So any of this, either this ortho-hydroxy component, this one, or a para-hydroxy, either of this can club together and form a different polymer. So we will take, for example, ortho-hydroxy. So different, this is a one of the monomer. This monomer will be joining or will be giving together a product called as a polymer, and that polymer is nothing but a polyphenol formaldehyde. See now, okay. Now this hydrogen from one monomer and OH from another monomer will be eliminated as water molecule. Okay, are you getting? So this is a one monomer, this is a another monomer. OH from this and hydrogen from this is eliminating as a water molecule. See the product over here. So the product that you will get here is a Novolac. These monomers can be repeated several times to get a n number of this. So this is named as a Novolac. Okay. The simple thing, which kind of this polymerization is? It is a condensation polymerization. So from the difference between that, we have seen that condensation polymerization, when there is a condensation polymerization, the polymer which is formed is a thermosetting. Okay. So there is a elimination of a water molecule which will result into the polymer named as a Novolac. Okay. Now the uses of this is having a excellent electrical insulating property, which because of which it can be used for the preparation of a plugs, switches, switchboards, okay, different handles. It is also used in a cation exchanger resin. This is very important use of this polyphenol formaldehyde. It is used in a cation exchangers. Okay, then it is, as it is a electrical insulator, very good electrical insulator, so it is used for all kind of a preparation of a switchboard, switches, plugs, handles. Okay, so these are some of the important uses. It is used in a paints and varnishes. Paints and varnishes are also containing this Novolac. Okay, the next preparation and use is of a PMMA, which is termed as a polymethyl methacrylate. So we will see the preparation of that. Okay, this is a methyl acrylate. Okay. So this is a addition polymerization takes place and you will get a product. Okay. So just a addition polymerization taking place. This is a monomer which is known as a methyl methacrylate. This is a methyl methacrylate and this is a polymethyl methacrylate. Okay. So very simple it is addition polymerization, it is an example of addition polymerization. Our first one was an example of a condensation polymerization where there was an elimination of a H2O molecule. Here it is an example of addition polymerization, just because only one monomer is added several times to get n number of that particular monomer, hence it is a polymethyl methacrylate. Okay. So it is again having a very significant importances, or we can say significant uses. Okay, like this PMMA, polymethyl methacrylate, is having a more transparency than glass. Okay, it is having more transparency than glass. Therefore, it is used in a preparation of optical instruments. Optical instrument parts. Okay. It is also used for the preparation of a window glasses. That is again very important use. It is used for the preparation of a contact lenses. Okay. So you can see that it is more transparent than glass also. Hence, it has a almost uses which are wherever the glass is used, that is optical instrumental parts, window glasses and contact lenses. Okay, so this is again very useful polymer. The last one that we are going to see is a Kevlar. Preparation of a Kevlar. Okay. Now this is again a kind of a condensation polymerization where two different monomers are taking part and there is a elimination of a simple molecules. Now what happens over here is, this is terephthalic acid and this is para-amino aniline and this is terephthalic acid. Okay. So this is one monomer, this is another monomer. These both are undergoing a condensation polymerization where HCl is removed now. Okay, a simple molecule like HCl. See here now, we can write this in this manner also. So this Cl from terephthalic acid and hydrogen from para-amino aniline are removed as a HCl molecule, and therefore it leads to the formation of a new polymer called as a Kevlar. This is a structure for a Kevlar. Okay. So example of again a condensation polymerization. Now this Kevlar is prepared from a terephthalic acid and a para-amino aniline monomer. This is having a exceptionally used in a aircraft, aerospace. Okay, all the machinery parts of the which are used in a manufacturing of aircraft, also in a aerospace. So this Kevlar is having a very good tensile strength, or it is very hard, and therefore it has a uses in a aerospace industries. Okay. So this completes our 3 preparations and uses, that is PMMA, that is polymethyl acrylate, Kevlar and phenol formaldehyde. Thank you.